Hello. Okay. Good morning, everyone. These are going to be our slides on measuring inequality. So far, our discussion of economic development has essentially been focused on changes in average income per capita. So we'll look at the Solow model, Harrod-Domar model, or any variation that we looked at. Essentially, we were looking at a model where income referred to the average income per person in the population, and that was the way how we're going to measure income. Now, this is a useful way of thinking about development. We discussed, why that's a useful way, but essentially, it's ignoring other important aspects that we want to consider as well. And one of those aspects is how is that average income distributed across the population? Income is not distributed equally in most modern societies, but there are some members of the population which have higher income than others. And so that's what we call the income or the wealth distribution, depending if you're talking about the flow of income on a given period or the amount of accumulated wealth of assets that individuals hold. Obviously, those two are different because income is a flow over time and wealth is a stock that is also changing over time, but it's a stock. And so depending on the application, what we're thinking about, we may want to focus in either one of those. And so just briefly, why do we care about how fairly is income distributed? Well, we may care about it for ethical reason. It may be that we like to live in a society that is fair, or we like to live in a society that gives equal opportunities to people, and we believe for philosophical or ethical reasons that the economy's resources should be distributed equal among everybody. Now, of course, one issue with that is people may say, the reason why people have different incomes is that people have been working and making different decisions about investment in human capital and so on and so forth. And so in the income distribution really reflects the fact that some people have been working hard and making the right decisions, some people have not been doing that. And so if you try to equalize everybody's income, you're going to take away the incentive for people to make the right decisions. For example, if you're thinking about an extreme version of that, and you're saying, people should be given equal opportunity at birth to achieve the same economic wealth, then you have to get rid of economic bequests, and you can't allow billionaires to pass money down to their children, which seems somewhat unfair if those billionaires actually became rich, particularly because of the decisions and their hard work. Now, you may question those ideas, you may agree or disagree with them. I encourage you to think about them, but essentially, there's an ethical argument for living in an equal society or where income is equally distributed. But even beyond that, even if we don't care about inequality and we don't care if there's some people who have very little and people who have a lot per se, we may still find that the fact that the resources are distributed in a very unequal way may actually reduce the possibilities of overall economic growth. And so if we just care about the growth in average income, even if we just care about that, we might still be interested in thinking about inequality, as we may find that if the society has high levels of inequality, that may actually create problems like instability, violence, and so on, sickness, that may lead to actually a reduction in the potential of that economy to grow income per capita. And so those are two essentially different reasons for why we may care about inequality. So however way we may feel about inequality, the first step that we need to take is to discuss how we can measure inequality in a society. And so given a distribution of income for a country, which is how its income distributed among its population, how can we measure, how can we quantify how equally are resources distributed in the society? And there's two ways from which, two perspectives from which we can look at that. We can look at personal income distribution, so we can go household by household and see how much income each household has. We don't care about where that income is coming from. We don't care if the person is earning wages for the income, or if he owns an apartment and is receiving rent, or if the household owns some stock, or if they own a firm. We don't care about the source of the income, just about how much income each person is making or each household is making. Sometimes we may also care about how is income distributed across the different factors. So how much income is a wage, so it's a retribution for work, how much of the total income generated is a retribution for the use of capital goods like interest payments, dividends, profits for firms, um, rental like of an apartment and things like that. And so those are essentially two arguments. The factor distribution is something, for example, that Marxist economics faces a lot on. In this class, we're going to focus more on the issue of personal income distribution. Okay? So we're going to go through a sequence of different ways in which we can measure. Please ignore it says functional distribution thing now. We're not going to talk about functional distributions. We're just going to talk about size distribution, Lorentz curve, and aggregate measures like the Gini coefficient. Okay. So the first way, perhaps the most easiest way in which we can think about income distribution is to think about what is the percentage of the share of total income that a certain group has. So here we have a table, for example, for different countries. And so if we look at Bangladesh, the first country on the list, we can ask ourselves, if we put people on a line, based on their income, like when you go to school and they set you up on a line, the shortest to the tallest, if we put people on a line and we ask ourselves, okay, let's pick the 10% poorest people in this country, and let's combine all of their income together and ask ourselves, how much of the total income do the poorest 10% of the population are making? The answer for Bangladesh would be 4.3%. If you look at other countries like the United States, that number will be more like 2%. And so you can see that the very poor in Bangladesh actually have a higher share of the total income than in the United States. And also it's important to notice from this comparison that but United States is generally a wealthier country than Bangladesh. And so this is not to say that the poorest 10% in the United States have lower income than the poorer 10% in Bangladesh, or that are doing worse off. It's just that relative to the total size of the cake, we always make this analogy of the total income in the society as a cake. The poorest 10% in the US are only getting 2% of the cake, even though 2% of a bigger cake may end up being a bigger piece than the 4.3% that people earn in Bangladesh. And we can look at this for different fractions of the population, as is done in this table. We can ask ourselves, how much is the highest 10% of the wealthiest 10% of society? How much of total income do they get to keep? And we see that number for Bangladesh is 25%, more or less 26.6%. There's other countries like Zambia, where the wealthiest 10% actually make about 40%. And so that's, or in Colombia, that's 45, close to 50%. So the wealthiest 10% get half of the cake. Okay? And so you can see how each one of these, sometimes these are called Kuznets ratios, gives you an idea of how fairly the cake is distributed. And you can make the exercise thinking about next time you go to a birthday party and you see one guy eating all the cake, what would be the Kuznets ratio for that cake distribution? Okay, so this is these ideas can be applied to anything, any circumstance in which we're dividing up a certain amount of goods or resources. Okay, and so as you see from the table, this is also done for the first quintile. The quintile, a reminder, is the bottom quintile would be the lowest 20%, the poorest 20% of the population. Second quintile is between 20 and 40, and so on and so forth. And so, as we can see, this gives us a little bit of an idea of how fairly resources are distributed. Okay, so just to be clear, how this works, let's just think about a very kind of small society with 20 people. So let's look at this table where individuals are numbered. So individual number 1 is the poorest person in the society. Individual number 20 is the wealthiest person in the society. And so, so once we have them lined up here, the bottom 10% decile, the bottom decile would be just 2 individuals, because out of the 22 is 10%. And so we see that combined, these 2 people, the 2 poorest people in society, make an income of $1.8. And we see when we add all of the incomes here, when we add this personal income column, the total income in this society is 100. And so we see that the bottom 10% here in this society has a share of 1.8%. How about the quintile? Well, what is the bottom 20%? Bottom out of 20 people, the bottom 20% will be individuals 1, 2, 3, and 4. When we add up their 4 incomes of 0.8, 1, 1.4, and 1.8, we have that they have a total income of 3.2. So in this society, the poorest will have an income, the poorest quintile, the bottom 20%, the poorest 20% in society will have an income of 3.2% of the total income. Okay. And here, another important point when talking about income distributions, oftentimes when we have income distributions that are not very equal, like for example here, the wealthiest person in society earns 15, so the top, just one person here will be 5%, so the top 5% in society earns 15% of total income. You may have heard there was a movement about the 99% and the 1%, and it was called Occupy Wall Street. It came out during the 2008 crisis, and their whole focus was about discussing, or they often bring up this number for the top 1% and how the top 1% of the society has been getting a higher and higher share of total income for the United States and other developed countries. So these ideas have been manifesting themselves also in the political arena with people like Bernie Sanders or Elizabeth Warren in the United States, which often talk about the 1%, which they refer to the essentially the share of income that the top 1% of society is making. That's one point. Another point is that sometimes in this context, the mean income that we compute here to be equal to 5 is much higher than the median income. The median income just refers to look, okay, let's find a value of income such that half of the society has an income below that and half of the society has an income above that. And so that's the same as finding the 50th percentile. So here that would be the 10th person. And we see that the 10th person has an income of 3. Half of the society has an income below $3, and half of the society has an income above $3. And so the median income would be 3. When we look at the mean income, what we do is we divide the total income by the number of people. And so here the average income is 5, but the median income is 3. And you could argue that 3 is a more realistic number that describes what the typical person in this society is earning. This number, the reason the mean income is higher is because it's influenced a lot by the high values that the high earners have in the society. Okay, so that's a small comment on how we like to measure sometimes median income instead of mean income in this context. I will ask you if there are any questions, but you can't answer to me, so I'm going to keep going. So how we can represent, given the income distribution like this one, how can we represent graphically that information? One way is to draw an income distribution, but as you can see, sometimes this is not very useful other than just giving a quick graphical idea. And so sometimes we refer to what we call the Lorenz curve. And so what is the Lorenz curve? Essentially, the Lorenz curve would be to plot this column here of the deciles, or if we have it here in this society, we can only do it up to a fine grid of 5%. So we'll say, we come here, and we say, okay, the bottom 5%, how much do they make? 1.8 of total income. The bottom 10%, how much of total income do they earn? And we said, okay, that was 1.8%. And then here we come to 20%, we go back to the table, how much does the bottom 20% earn? Oh, that was 3.2%. So we mark 3.2. So the Lorenz curve just plots all of those numbers for any point on the Lorenz curve. what it's telling us is, for example, if we want to know how much does the bottom 50% of the society, the poorest 50%, so this is the percentage of income recipients on the horizontal axis, and going on the vertical, it tells us what is the share of total income. So here we see the bottom 50% in the society is earning, that would be point E, is earning roughly 20% of total income. Okay, and the 90% poorer people in this society is earning here, if you look at point I, is earning approximately 60%, a little bit over 60, let's say 65%, which means you can read the other way around. The top 10% is earning this vertical distance up, so that would be 35%. Okay. So that's essentially one way in which we can generalize this idea and just make a curve that gives us all of these points, all of these Kuznets ratios for all different percentiles of the income distribution that give us the Lorenz curve. Okay. Now, notice here, the line that joins these 2 points, it makes a triangle, is what we call the line of equality, because if income is shared equally, that would be a 45-degree line, and so the bottom 10% will have 10% of the income, the bottom 20% will have 20% of the income. It wouldn't really be the bottom because everybody has the same income, but you just say 20% of the population has 20% of the income, 30% of the population has 30% of the income, and so on. And that's what happens when income is shared equally. And so the Lorenz curve for a society where income is shared equally would be this line here, and that in the diagram is called line of equality. On the other hand, a completely unequal society will have all the income given to one person. So the bottom 10% will have zero income, bottom 20% will have zero income. And so the Lorenz curve essentially overlaps the horizontal axis all the way until the last person here, which has all the income. And so for the other extreme, one extreme is everybody has the same income, another extreme is one person has all the income, everybody else has zero. In that case, the Lorenz curve will be given by the vertical axis up until to this point and then going up this way. And so the Lorenz curve is somehow trapped in this triangle, which the top of the triangle, the line of equality, represents line of equality. The bottom of this triangle, the kind of that form a 90-degree angle, that will tell you what is perfect inequality, if you want, and the Lorenz curve is somewhere in between. And obviously, the further away from the line of equality, and the further closer you are to the bottom lines, the more unequal income is distributed. And so you can see that in this diagram, in the graph A, the Lorenz curve is relatively close to the line of equality. So here, not everybody has the same income, but it's pretty close to that. In graph B, things are a little bit different. The Lorenz curve is further away from the line of equality, and so we can conclude pretty comfortably that the economy A income is more unequally distributed than in economy B. Okay. Now, can we rank all of the economies just by looking at the Lorenz curve? The answer is no, because you could have circumstances where the Lorenz curves cross, and so it's not so easy to say whether, as it is the case in this graph, between Lorenz curve for economy B and Lorenz curve from economy C, when the Lorenz curve is not so easy to say which society has a more unequal distribution of income, because if you position yourself at the lower, let's say the bottom 20% is here, and you look, how is the bottom 20% doing in economy B versus economy C? At that point, the Lorenz curve for B is higher than C, and so at that point, you can see that the poor are richer in B than in C. So you may conclude, okay, B has a more fair income distribution because the poor are doing better. But when you come to ask yourself, okay, but how are the rich doing in B versus C? You can see that the Lorenz curve in B is lower than in C. And so that means that the rich are getting a higher share. And so you can think of this as the poor are richer in B than in C, but in B also the rich are richer than in C. And so to answer which one of these economies is more unfair, you have to take a stand, make a decision of which one of those two things is more important for you. Okay? And so here's a very simple example of two economies with 5 individuals. And so ask yourself which one of these societies seems more fair. In the first economy, let's call it economy A, when you ask yourself, the bottom 20% have 5% of income, 10%. So it seems that income is more unequally distributed. So the poor are kind of doing worse in society A, but at the same time, when you look at society B, the rich person has significantly higher income relative to the poor than in A. And so which one should be considered more unequal? Look here, the first 4 people in society B have equal incomes. That seems very fair, but then they have a much lower income relative to the wealthy guy in the society. Whereas in economy A, incomes are all more unequal, but the richest person are closer to the poorest. And so which one should we regard as more unequal is not so clear. And that gives you a more general point that it's not necessarily a trivial task to decide which society is more unequal, especially when you're talking about societies when the Lorentz curve crosses. So sometimes that may be relatively easy when the Lorentz curve of one society is above the other. Sometimes it may be harder when the Lorentz curve cross. Okay, so that's a general message. Now, sometimes just having a curve is too much, and we like to have just a number that summarizes all of that information. And in this context, we can have that number described as the Gini coefficient. And essentially, the Gini coefficient is trying to measure how far is the Lorentz curve from the line of equality by looking at the area A, which essentially, if you ask yourself what the area A essentially is going for each point and asking, okay, let's pick, for example, a point here, let's say the bottom 20% of the population, the poorest 20%, how much of the share of total income do they have? That would be this point here. And this vertical line, if you come up here, that would be equal share. So that's telling you, let's say the bottom 20% has 10%, and then equal share would be that they have 20% of income, then this vertical line would be the distance of 10%. And so when you're computing this area, essentially you're adding up for all shares of the population, how far you are from the line of equality, and that gives you the area A, but you would like to normalize that, and so to get a number between 0 and 1, and so then you would divide by the total area of this triangle, which is the highest possible value that you can get, the triangle B, C, and D, and so when you divide by that, you get something between 0 and 1, that when you are in perfect inequality, area A is equal to the area of the triangle BCD, and so the Gini coefficient is equal to 1. When the Lorentz curve is equal to the line of equality, area A is equal to 0, and so when you have perfect equality, the Gini coefficient is 0, and then for intermediate values, the Gini coefficient just gives you one number that summarizes the degree of inequality in that society. Okay. And the Gini coefficient doesn't have to be used only for income distribution. It could be used, as we will see, for example, for how we want to think about how equally is the distribution of land or other resources in a society. We can apply the same ideas. We have to construct a Lorentz curve and then aggregate all of that information into one number by looking at the area between the Lorentz curve and the line of equality, and then dividing by this constant to normalize it between 0 and 1. So as I was saying, the Gini coefficient aggregates all the information in the Lorentz curve into a single number. We describe how you can obtain it. It's a number between 0 and 1, where 0 is perfect equality, 1 is perfect inequality. It's an aggregate measure, which means that you could have two countries that have different Lorentz curves, but they end up, when you aggregate them, you end up with the same Gini coefficient. And you can draw a graph and try to convince yourself of that. Or you could have two different societies that have different Gini coefficients. So according to the Gini coefficient criterion, you would say one is more unequal than the other, but the Lorentz curves cross, and so it's not so clear. And so which one should be more unequal from a more fundamental level. And so what this should tell you is that the Gini coefficient, if you go back to our idea of what happens when Lorentz curve cross, we really need to have additional assumptions on whether do we care more about the poor people in the society or the rich people in the society and so on. And so essentially the Gini coefficient is making some assumptions about that for you. And that's why you end up getting different Gini coefficients when Lorentz curves cross, where ideally you would like the Gini coefficient to tell you you can't compare this number, but the sheer fact of aggregation is forcing you to make an assumption about that. Okay? So those are the general ideas about, or the basic ideas of Gini coefficient. Sometimes you can derive the Gini coefficient, or you can show that the Gini coefficient has some desirable properties. This is sometimes referred to as an axiomatic approach. The way you work with axioms in mathematics is you describe some properties that you would like your measure of inequality to have, and then you derive a measure that has these properties. And so here, we're not going to go into the mathematics, but you can show that the Gini coefficient has some nice properties. Those properties are as follows. The first one is anonymity, which means it doesn't matter who earns the income. It doesn't matter if it's Tom, the richest guy, and Mary is the poor one, or if I switch them up, and I switch Tom's income for Mary's income, and now Mary is the richest one and Tom is the poorest one, if the relative income didn't change, the measure of inequality should not change. So we shouldn't favor Mary or Tom over Mary. We should look at incomes, not who is the person earning the income. Second property is what we call scale independence, which says that measures does not depend on the size of the economy or units used to measure the economy. So our measure should not depend on whether we measure things in dollars or thousands of dollars. So a linear transformation of the units in which we're measuring income should not affect our measure. And also, it shouldn't be affected by the mean income. We're looking at relative incomes, but it shouldn't matter if we're talking about Bangladesh economy or the US economy, where what matters is how much of the cake people are getting, but not the size of the cake, okay? And it can be shown that the Gini coefficient has that property also. Population independence refers that our measure shouldn't be biased by the size of the economy. In other words, if we're comparing China and Switzerland, our measure should not depend on the fact that China is much bigger than Switzerland. For example, if we're looking at one society with a given income distribution, and then we create a replica of that society, for every person, there's two people with exactly the same income, both of those societies should give us the same measure of inequality. We're just kind of scaling things up, but we're not changing the relative income distribution. And so that's the idea of population independence. And finally, and perhaps more importantly, the idea of a transfer principle simply wants to make sure that we're indeed capturing inequality and not something else, which is to say that if Bill Gates takes $100 and gives it to me, that should reduce inequality. Now, if Bill Gates takes all of his fortune and gives it to me, then now me and Bill Gates are switching places, and so that would essentially go back to anonymity. But transfer principle, as long as the transfers are small, any time that a rich person is making a small transfer income to a poor person, that should make inequality go down. Okay. And so here we have a few data points of income inequality. I encourage you to go to Gapminder, where you can find graphs that show this relationship more clearly on how different countries do. Remember, the larger the Gini coefficient, the larger the inequality. I think the general take is that you have countries like the United States, which have relatively the same income inequality as Cambodia, and you have low-income countries like Ethiopia, which have much lower inequality than Spain and the same level as Germany. And so it doesn't seem to be a clear pattern. And this is kind of why this property number 2 of scale independence is relevant. We would expect this kind of like building somehow, but there's no clear correlation that richer societies distribute resources more fairly. Some societies like Norway, perhaps Germany, do. Others, like the United States, perhaps Spain, don't do so much. Okay, so this is a general trend that we find. Now, is the Gini coefficient the only measure of inequality that satisfies those four axioms? The answer is no. Another measure of inequality that satisfies this is called the coefficient of variation, which essentially is a rescaling of the standard deviation. And so you guys are familiar with the standard deviation from statistics. When you're looking about the grade distribution of your exams and you ask, well, what's the standard deviation? You want to know how concentrated were the grades around the mean grade. The coefficient of variation is asking how concentrated are the income around the mean income. The higher the standard deviation, it means the typical income is farther away from the mean income, you have further distance. And because of the properties of invariance to scale and so on and so forth, we want to get rid of units, and that's why the coefficient of variation divides by the mean income, because the standard deviation is in units of income. When you divide by the mean, which is also in units of income, you end up with a measure that is unitless. And so this measure can also be shown to satisfy all of those nice properties. So this is another way in which we measure inequality. Okay, so this is the end of our lecture on measuring inequality.